Alright, time for another draftphysics.com, debatephysics.com. Also, video presentation number 5 in a volume of videos done for the purpose of soliciting an actual video response, some sort of reaction, okay, that points out where in these videos I have made egregious errors and stated things that don't happen in the actual physical world, something like that. And I am willing to pay people to make these responses, obviously sort of contingent on their capacity to provide audience and more interest in the subject. So if you're not going to be able to advance the exposure to these questions, then it's likely I'm not going to pay you much. But let's just say I'm willing to pay a minimum of 20 for any, almost any video that actually contains my video in the video response. So anyway, bowling is the subject of this short, hopefully. And it's sort of a simple argument. Obviously, the kinetic energy theory, 1/2 mv squared, has implications. And one of the implications is it basically says that an 8-pound bowling ball thrown with 16 velocity has twice the energy or capacity to do work as a 16-pound ball going 8 velocity. Now, the simplest argument I can make is it won't do anything called work because it'll produce exactly the same momentum. So there won't be any extra momentum. So there isn't much logic to the argument that somehow it has more energy and can do more work if it produces exactly the same momentum in the end. It conserves the momentum. So these numbers, 12.8 would be the momentum of the 8-pound ball, 12.8 is the momentum of the 16-pound ball, and that is all perfectly conserved. And this little chart here sort of indicates how that conservation takes place. The 8-pound ball will hit the first pin and make it go twice as fast as the first pin the 16-pound ball hits because of the difference in the velocities. I don't know if you can see that. Maybe I'll use this stupid arrow. Hello, stupid arrow. Stupid arrow. I want the stupid arrow. I mean, this is not much to ask from a program to be able to move the arrow. Alright, so yeah, they have the same momentum. And the claim is that the kinetic energy of the 8-pound ball going 16 is 1,024 joules. I have converted the newtons into joules over here. The 12 numbers in joules. So a dramatic difference in what momentum says the energy is versus what kinetic energy says. And obviously half is what you get, the KE, but you have the same momentum. So anyway, it's supposed to do twice the work. And yes, when the 8-pound ball going 16 hits the first pin, it's going to give it, a substantial double the velocity. The 16-pound ball is going to give the first pin. So if we just said they were 4 pounds pins, and let's just say they can give all, a substantial part, 4 pounds, a lot of energy to the first pin and the second pin. You could sort of understand just using 2 pins and saying all the momentum or all the kinetic energy is just going to be given to those 2 objects. And you could sort of understand just from that, that the second pin it hits, it's going to be going substantially slower. So if you understood that the first pin is 4 pounds and it's going to be going 16, that's half the momentum of the 8-pound bowling ball. So when it hits the second pin, it's only got, half of its velocity. So it's only going to be going 8, not 16. Its velocity is going to be substantially reduced. And because of that substantial reduction in the velocity, obviously the kinetic energy won't be anywhere near conserved. So the expectation is you start with kinetic energy of 1024 and you end up with, in the final result, with 640. So almost half the kinetic energy is gone, missing. Same thing in the other example with the 16-pound ball, only even more dramatic. You even lose even more kinetic energy. So a dramatic failure of the kinetic energy to be conserved And so we're supposed to believe that when the ball hits the pin, it made so much waste heat, okay, that that's where you had to lose it all. Obviously, all the pins will eventually stop and all of the motion will be converted into heat. But the real argument is before that happens is where this waste has to happen. So somehow we're supposed to believe that, the 8-pound ball loses half its kinetic energy, and the 16-pound ball will lose 2/3 of its kinetic energy. In the same, but you must also understand that all of the momentum will be perfectly conserved. So we're supposed to believe it makes heat, but somehow it didn't use any momentum to do it. So I could use a bowling ball as an example. You can't knock down pins. You can't make heat. Heat is like little pins. You can't knock down a bunch of little pins and still have all your momentum. That can't happen. So anyway, just dealing with this chart again, you can see that the top line would be the 8-pound ball, and it's going to cross over the 16-pound ball. And so in the end, they'll both have the same advantage space in the sense that the 16-pound ball will be giving more momentum later to each pin, and the 8-pound ball gives more momentum earlier. And that's the only difference. But in the end, they're going to move exactly the same amount of mass of velocity, and that's not going to change. If you add up all the velocity of all the pins and all the mass of all the pins moved, it's going to be exactly the same amount. And the punchline is, in spite of their theory, no professional bowler chooses to use a lighter ball, even though it's supposed to have twice the energy. Now, there is a subtle gravitational reason why there's an advantage to a 16-pound ball, in the sense that you don't, when you're bowling, the lifting energy is basically the same for both balls, and the swing arc is going to be about the same for both balls. Obviously, an 8-pound ball, you could probably swing it up higher, but it's probably not going to be enough to get a gravitational advantage. So the fact is 8 pounds falls at the same speed as 16 pounds, so you obviously don't gain quite as much energy from an 8-pound ball just falling the same distance. But again, the argument is you can throw it, your backswing can be higher, and you can gain more dropping momentum in an 8-pound ball. So it's a subtle but real variable that I can't account for one way or the other. I can't say there's an advantage or disadvantage. I'm just pointing out that it is a variable. But again, the argument that they make is somehow that people can't throw 8-pound balls twice as fast, and that's why bowlers don't use them. But they have no evidence they have no experimental evidence demonstrating that a bowler can't throw the 8-pound ball twice as fast. So until there's evidence of that, it seems just a desperate hope that they can evade the simple truth, which is this experiment once again demonstrates that kinetic energy won't do more work, and it can't do any more than conserve the momentum in the end. And so it can't do more work if it's the same momentum. So anyway, probably enough of an argument, and so I'll put this back where it belongs, but it wasn't that useful. Alright, anyway, so till the next time and such. I mean, it's just another piece of evidence that says, well, if this theory was right, why wouldn't people be throwing 8-pound bowling balls? Twice the energy is a lot of energy. And obviously it's because it's not energy that actually does any work. Fact.